Hello and welcome to CSES Tech Talks. Today I'm joined by Dhruv Sharma. Dhruv, who are you?
Hi everyone, I'm Dhruv. I'm the president of CSES Innovate and the project lead for Skin Lesion Detector, which is a project within CSES Innovate. Innovate is UCSD's first student-led research group and startup incubator. The idea is that we want to grant students the freedom to explore and build something, possibly for the first time, and learning about what it takes to do research and build something from scratch. Classes in UCSD, and I don't think in universities around the country they don't grant such kind of exposure into the real world. And research labs are incredibly difficult to come by, especially early in the academic journey. So I can give you my example. In my second year, I sent around almost 60 to 70 emails to professors, and I got like two responses. I want to provide the students at UCSD a community where they can pitch their ideas, work on their ideas, and just put it out into the real world, get some experience into building something for the first time at that kind of scale. So that's the objective of CSES Innovate.
So, what are some of the projects that Innovate has worked on?
Yeah, so Innovate has worked on two projects in the past, but I'll focus on only one of them. This one's called the Virtual Try-On Network. So it's a piece of software that allows users to try on clothes virtually before purchasing them online in order to save them the trouble to return those clothes. So Viton offers like real-time webcam virtual fitting via diffusion models and pose estimation. It allows users to visualize how the clothes look and move on their own bodies before actually purchasing the product. And this software requires nothing more than a standard webcam. So Viton warps the lower and upper garments onto a live video feed and preserves key visual features like fabric texture, garment structure, and motion consistency. Currently, it supports 11 garment categories and latency is under 2 seconds, providing a seamless shopping experience for users. So this project was presented at the CSES UCLA conference hosted by Bruin AI, and the paper is going to be published at IEEE Transact by the end of the quarter.
So, with that being one of the past projects, what are the future projects that Innovate is looking forward to?
Yeah, Innovate is looking at two upcoming projects. One is AID, which is a intent-based coding assistant, and the other one is Agent Space. So I'll focus on Agent Space this time. So Agent Space is actually quite an interesting project, and it's basically a marketplace for AI agents. So the idea for Agent Space is that we want to democratize access to talent for people who may not be able to afford real professionals and the talent at that high of a level. So, for example, if there's like a really great college consultant and they're charging like, I don't know, something crazy like $200 an hour. What I'm aiming for is that college professional, that college consultant can create an agentic version of themselves and put it on this marketplace for say something cheaper at like $50 an hour or something like that. So this allows a lot more people to access that kind of talent without needing to pay as much as they would have to actually hire that talent. We're trying to bridge that talent gap through agent space, and we're doing that through custom system templates, through a custom agentic workflow for each professional. We're taking into account their past work, their personality types, and all in all, we're creating an all encompassing AI agent that can be put out into the market, onto the space marketplace.
So, if there are people who are interested in doing this kind of work, what do you think is a good place to start if you're interested in machine learning?
That's actually a really great question. I've come across this many times in a lot of events hosted at CSES. I'd say everyone should start from the start. Although LLMs and AI agents are like the hot stuff right now, I don't think people should start off with that. I believe it's important to understand the basics of how each step of the how LLMs are working under the hood. So what I'm trying to get at is that people should learn the basics of machine learning. For example, gradient descent, linear regression, then building their way up into k-nearest neighbors, neural networks, convolutional neural networks, LSTMs, and finally move on to transformers, which is what's powering LLMs. is the underlying architecture for LLMs. So some resources to learn exactly how, like to learn the entire stack is like one person is Andre Karpathy. He has a video series on YouTube called Zero to Hero, where he takes you from the basics of machine learning to creating GPT. He dives into granular details about like hardware optimization, hyperparameter tuning, dataset curation, etc. And I believe I learned the most from that course because while he's teaching and coding, he's also reading research papers on the side. That was actually my first instance of coming across research papers and using them to write actual code. So I'd say people should watch Andre Karpathy, and there's a course on Coursera on deep learning specialization by deeplearning.ai, hosted by Professor Andrew Nee. So I'd say these are two great places that people can start with. Yeah.
Uh, Another thing, just to add, I know it's a bit late, but I do believe Innovate also has a kind of learning workshop that they run now. Is that true?
Yeah, it's it's Innovate cohorts. Yeah. So
Okay.
we're trying to like give people the underlying fundamentals to actually build something. So we're taking them from the entire stack. Like we're teaching them how Git works. We're teaching them how gradient descent works. We're teaching them how they can actually write code, like using write code in like Python. We're teaching them how to use PyTorch to create machine learning models, and then we'll move on to using LLMs and creating something useful. Yeah.
And during that, you mentioned having to read papers.
Yeah.
And reading papers can be very scary. Papers can be very dense. They can have, especially computer science papers, can have some complicated math in them. Do you have any tips on kind of getting into reading papers? Because that's very important when doing machine learning research.
Actually, yes. The first step to reading research papers is to not be afraid. This, like, I don't think it's not very widely spoken about, but I think, at least in my experience, I'm like, okay, there's a research paper. It's 30 pages. I'm a bit scared. I don't know if I'll be able to read through all that. The first step is to just believe in yourself that you know you can actually read that. It may be difficult, it may not be difficult. You don't know that. So the first step is to win that battle, to believe in yourself. The second step is to actually start reading, and when you're reading, just have a notebook on the side and just write short notes about what's being spoken about in that particular section. So if you're reading the introduction, just write a short summary of the introduction so you actually understand what the introduction is talking about. Then the background, then the methods, then the experiment results, conclusion. So just keep writing short notes is what I'm trying to get at. And yes, when you inevitably come across ridiculously complicated mathematical formulas, just use ChatGPT. It's a great resource at this time. You can also use Perplexity. Perplexity is quite good if you really don't understand what's going on in the paper. It allows you to research. It allows you to conduct deep research. It'll explain it'll explain what you're having doubts in fairly good detail without being too technically difficult to understand. So that's these are two online resources you can use. And if that also fails, ask a professor if they're willing to read it with you. Professors are most likely to be they'll probably say yes. They're very down to they've been researching all their lives. They'll be very down to help you out. And I haven't personally asked the professors yet, but in my experience, I have heard other people ask, and they're very very open to helping students out because that's half their job here. It's just teach people, and teaching how to read research papers is a skill that takes years to refine. And I think professors are at a level where they can actually give you actionable advice onto reading research papers.
I do want to end this with one kind of personal question, because I like throwing that in. This one's more for UCSD students, but do you have a favorite upper div computer science class that you've taken?
Favorite operative? I haven't taken too many operative classes yet, but one of my favorite ones was 50 CSE 152B by Mohan Chandrekar, Professor Mohan Chandrekar. It was the second iteration to the computer vision series. So we had 152A and 152B. 152A was not very enjoyable because it was very math intensive. It was like building the foundation to 152B. And I didn't really particularly like 152A, but when I moved to 152B, I loved it because we were actually reading research papers, and based off that research, we were implementing those implementing the methodologies listed in that research paper onto our code base. I really love that because I believe that's what we're most likely going to be doing in research, like at a later stage. And I think that's what we're going to be doing. That's what we do at Innovate right now. That's what I've been doing at my research lab for like the past year. I really love that class because it gave me actual like it gave me actual experience on how the real world is working. So yeah, I'd say I love 152B.
Great. Thank you very much for coming on, Dhruv.
All right. Thanks for having me.